calculate area of regular shapes, and we're going to take a look at a number of regular shapes. So to find the area of shapes, think of the shape as sitting on top of a grid, okay? And we're going to count the number of squares inside of the shape. Now, I do have a grid on some of these, actually a whole bunch of these, and but it's a little bit tough to see. We'll try to make at least get a good look at them at some points. On my original copy, it turned out a whole lot better. Maybe it's the printing that did it. So let's take a look at the first shape that we're going to do is a rectangle. Now, if we take a look at this rectangle and count the shapes, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There are 28 squares inside of this rectangle. Okay, so there are 24 squares inside this rectangle. Now the thing is, we don't know what unit they are because we're not told that unit, but we're told that there's 28 squares, so our area is 28. Now, if the length of a box or a rectangle here was given, the area of the rectangle would be based on that unit. Okay, the units inside used in the area will be dependent on the length of each little box inside. So if this is a length of, let's say, 7 centimeters, each one of these boxes is 1 centimeter in size, so this would be 4 centimeters. Okay, so this would be a way of measuring out a rectangle. Okay, what is the length, what is the width, or the height and the base, depending on what you use. We know there's 28 squares here, so this is 28 little centimeter squares. Okay, and that would be how we could write it out. This would be how we would write out if we know that these are going by centimeters. Now, to calculate the number of squares really quickly, instead of counting them all out, we can multiply the length of the rectangle by the width. And I'm going to call this the length, and I'm just going to put an L here, okay, for length, and this the width, and I'm going to do a W. Now you'll notice I have a stylized L. The stylized L is because just a regular L looks like a 1, so I use a stylized L instead of using a capital. It's just something that some teachers use. So to find the area, and here's our formula, the area of a rectangle is equal to length multiplied by the width. Or we can write out like this here, area, and I'm just going to do REC for rectangle. I'm using a subscript here. It's a little bit lower. So the area of a rectangle, because we'll deal with a lot of area formulas, so it's good to have kind of a definition of which, is length times width. I have a little dot there, or you can put the two letters together and just do length and width. So that's for a rectangle. Now a square is, okay, is just a special case rectangle where both the length and width are the same measurement. Now, I'm not going to really get into the fact that they're exactly the same, or a square is a rectangle. Just understand that. Maybe we'll do that in class. We'll kind of go over the fact that a square is a rectangle. But for now, just understand a square is a rectangle, so we can use the same. So the area of a square, I'm going to do a little SQ there, is just, so this is length and this is length. They're the same thing. It's just length times length. Or we can write it out as the area of a square is equal to L times L, or L squared. Okay, L times L is the same as L squared, remember, with exponents. Two numbers multiplied together that are exactly the same will be L squared. So this one right here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is 16. If we find the area of this square, it is 4 times 4, which is 16. This is 4 units. This is 4 units. The area is 16 as we multiply them together. Okay. So that's a square. A parallelogram, on the other hand, okay, I just gotta find this in my notes here. Okay, has 2 pairs of parallel lines. Okay, this line is parallel to this line. They're running exactly the same. And this line is running parallel to that line. Now, a rectangle and a square are what we would consider special case parallelograms because their edges are parallel to each other as well. It's just that we think of a parallelogram, some of them are slanted, so to speak. To find the area of the parallelogram, what we need is we need our length right here, and we need another measurement. We need the height of the parallelogram. We could also think of this as being the height. Okay, so that would be our height. So it is base time, or sorry, length. I should put that in as length. It is length times height, or length times width, if you want to call that the width. So the area of a parallelogram is length times height, or base times height, if you want to call that the base. Some people like calling that the base as well. So to find a parallelogram, just length times height, and the height would be the distance between our parallel lines. A trapezoid, okay, looks kind of like a rectangle surrounded by two triangles. Okay, so we think of it as being kind of like that. So a rectangle with two triangles, that's in fact a square, but it could also be a rectangle. Now, to find the area of something like this, we could find the area of each of these right here, plus this one, and add them all together. Or, I'm going to call this little b and this one big B, and this inside is going to be the height. And so to find the area of a trapezoid, and I'll go through an example of this, we'll take 1/2 times little b plus big B. What we're doing is we're finding the average of these two, and we're going to multiply that by the height. Okay, so we're going to find the average of these two sides and multiply it by the height, and that gives us the area of the trapezoid. So let's do a couple of examples dealing one with each type of problem. So the first one right here, this is a rectangle. Now the area of a rectangle is equal to length times width. We're going to call this the length, this the width. That if you can do either or, it doesn't really matter which one you pick to be the length and the width. And so the area of this rectangle is 10 meters times 11 meters, which is the same as 110 meters squared. And so our answer will always be in units squared. That will be the answer to an area question. Again, a square is also a rectangle. So the area is length squared. Our area is 7.5 miles squared, which you can gladly use a calculator for these because some of these are going to be way too difficult to do in our heads, is 56.25 miles squared will be our answer. Next one here, 3. Here we have a parallelogram. This is our base, this is our height, or sorry, this is our length, call it the length. And so the area of a parallelogram is equal to length times height. So area equals 5.3 miles times 4 miles. Now you'll notice I always put them into brackets. It's just how I kind of section off each of the measurements. And this is going to be the same as 5.3 times 4 is 21.2 miles squared. Okay, and so that would be our final answer to the area of this. If we have 1 mile squares, we could get 21.2 of them into this parallelogram. And the final one is a trapezoid. So the area is equal to 1/2 little b plus big B times the height. So the area is equal to 1/2, and this is 1 meter plus 3.6 meters times 1.1 meters. So we need to do this part first, and I'm going to do this in order here. Okay, 1 plus 3.6 equals, that's inside of our brackets. We multiply it by 1/2, which is the same as 0.5, and then we multiply it all by 1.1, and we get this area to be 2.53 meters squared. And that's going to be the answer to that question. Now, questions 1 and 2 on your assignment deal with those 4 shapes.